The goal of the chain is to provide IBC execution on behalf of connected chain. And I think like long term, this is the model that chains are going to move towards. I'm thinking that 50 is probably the upper bound for number of like meaningful EVM L2s. I sincerely don't believe that the current approach taken by existing solutions will scale. I'm actually a lot more bullish on the idea of...
Welcome to the Bare Metal Podcast.
Hey everybody, welcome back to the Bare Metal Podcast. Thanks for tuning in. I'm your Ship to Code from RockOIX, and today I've got here Bo Doof of Polymer Labs. Welcome.
Nice to be here. Thanks for the invite. Excited to talk about the number of topics we have prepped for today.
Super. So let's start with the first one, and that's you. Who are you? How did you get into crypto? Can you give us the rundown?
Yeah. My personal background started in Web 2. So I worked at a number of startups, ranging from small to somewhat larger ones. I worked at Uber on one of their software infrastructure teams. I worked on this like metrics and monitoring database called M3. Ended up leaving to help start a company called Chronosphere. Joined that company as the first hire. I was a core database engineer there. And I think the love for databases kind of carried over to blockchains. I really just see blockchains as just another type of database system, albeit it's Byzantine fault tolerant. There's other conditions that you want to satisfy when you want to make it decentralized. You're not just running like Postgres configured by like an etcd cluster or something. There's there's a lot of interesting considerations, I would say. And I think during my time at Chronosphere, I was kind of exploring and playing around in the DeFi space, trying to learn more about DeFi, experimenting with some of these various like DeFi protocols as well as interop protocols. And I realized that there was this like gap where there needed to be a lot of work done to ensure that the world or the ecosystem as a whole converges to a single unified interoperability standard. And even at the time, it was kind of clear to see that there was going to be some fragmentation going on, and we're continuing to see that fragmentation grow.
To put it mildly.
Yeah, exactly. It's kind of funny. Like in the Cosmos ecosystem, there's kind of IBC was there from the start, so like everyone can kind of rally and agree on at least like one thing among others. And in the Ethereum ecosystem, it's kind of like everyone just doing their own thing. So we hope to change that in the future.
So that's why you guys founded Polymer Labs. Who are your co-founders? When were Polymer Labs founded?
Yeah, we were founded in 2021. Actually, I wasn't. So when I first started the company, I didn't think that we would raise capital, or that wasn't my assumption going in. I had moved to Thailand. I quit my job. I moved to Thailand, and I was just living there, kind of hacking on like the initial version of the product. And it was during that time period and I didn't actually know about IBC then. It was more of one of the most popular cross-chain projects then was ThorChain. And we kind of had this idea to say, if we take ThorChain, we remove the DEX logic, it has threshold signatures, we can kind of, build this interop protocol off of this. This is like the foundation for an interop protocol. That's actually, pretty much what Axelar is. So we're thinking that in the beginning, but as I was, playing around with different technologies to use, we decided on using the Cosmos SDK. And as I learned more about IBC and as we were designing the protocol itself, we were like, oh, wow, we're like, if we want to add all the features that IBC has, we're going to get something like very similar to IBC, just in a completely different way. So that's why we kind of shifted focus to IBC like pretty soon. I'll say like end of 2021. That's when we raised capital. Myself and my co-founder, Peter. Peter's on the business side, and he has like a strategy consulting background.
Okay, so that's a pretty interesting sort of development there, moving toward IBC from a custom blockchain. And so recently, I saw, I don't remember if it was a tweet or a blog post that you guys are considering becoming an ETH or focusing on becoming an ETH L2 instead of being an app chain, which I take. So the basis of the app chain was supposed to be a ThorChain sort of modification, or is that separate?
No, the original one, the hacky thing that we were doing in the beginning was a ThorChain modification because I was just working on it by myself. I just wanted to make something that I could like demonstrate that it could work. But the app chain that we're working on, and it hasn't changed yet since then. There's a few innovations. One of them is called Virtual IBC, which we'll talk about later. But the goal of the chain is to provide IBC execution on behalf of connected chains. So like the goal of that app chain is very different. It's all custom code that we wrote ourselves.
So when you say execute on behalf of other chains, can you compare how IBC works between chains now and how it would work like with your chain in the middle there executing on behalf? Because I just have a hard time wrapping my head around it.
Yeah, so normally you would have to integrate IBC as a library. So you have to take IBC Go or IBC RS. There's also IBC Solidity. That one I would say is not like one-to-one with IBC Go. IBC Go is much further along. There's certain things that you can't do. It also is not like super performant. So you take one of these implementations, you add it to your chain, and now that your chain has any of these implemented, you're able to act as a counterpart. So any other chain that implements IBC, you can basically talk directly to them as long as there's some agreed upon IBC client that understands the state of the other. The two chains can now converse. With Polymer, we make it so that you don't have to natively integrate this library. Polymer executes IBC Go on behalf of the connected chain. So we actually execute IBC Go twice, like once for the connected chain and once for Polymer, if that makes sense. So like we try to make it so that the chain that's connected looks just like another IBC chain in the network. And the reason why we wanted to do this is because we wanted to give the option of if the chain one day decides to integrate IBC natively, we wanted them to have a clear upgrade path from using Polymer to a native integration seamlessly. So the idea is that at some point, if they were to have IBC integrated natively, you could have an IBC channel. You would just say, okay, let me just upgrade this IBC channel to use a different set of connection IDs, and boom, like you're on a native connection versus like a hop over Polymer connection.
But let's go back. So I've got chain A that wants to send an IBC transaction to, or user on chain A wants to send a transaction to chain B. So yes. If we're in the nominal standard situation where both integrate IBC, there has to be a channel that's open between them, right? Some relayers in the middle, and then user can just trigger the IBC transaction. Relayer picks it up, commits to the target chain, then goes back and commits the ACK. Everything's dandy. I sort of understand how this works, but now there's Polymer in the middle, which is acting as a counterpart. Like it's executing IBC. You said it's executing IBC twice. Can we dig into this one more time? And then how does Polymer talk to the target chain? That's what I'm interested in. So if I'm on the source chain and I want to execute a transaction that talks to the target chain, but there's no IBC on the target chain, can you like go packet by packet, let's say?
Yeah. So normally, let's say you're on Osmosis and you want to go from Osmosis connected to Polymer connected to Base, for example, and Base doesn't have IBC implemented. On Osmosis, you would say, I want to send a packet over these two connection IDs. There's going to be one connection between Osmosis and Polymer. There's going to be another connection between Polymer and Base. I'll get into what that connection looks like in a second. And there's these two connection IDs. So you've established an IBC channel over this two connection hop between Osmosis and Base.
And just let me interject, that's because Polymer knows that these connection IDs should be routed by Polymer to Base. Right? Whatever comes over these two connection IDs from Osmosis, you should go and talk to Base.
So connection IDs are relative to the chain that they originate from. So Osmosis's connection ID to Polymer is something that only like Osmosis is aware of. So like Osmosis knows.
Oh, okay. So Polymer isn't aware of the connection ID. Okay.
Yeah, anyone can connect to Polymer. Anyone can create these connection IDs. Polymer is only aware of like connections relative to it. It's kind of a funny thing. Like none of these connection IDs are actually associated with any chain IDs. If you have a chain ID construct, it's not really it's just kind of like a social consensus around what that chain ID
it's
means.
A crazy namespace anybody can come up with. I don't know what has there a chain IDs ever been duplicated? Like what if I spin up a chain that's called Osmosis 1? I don't know if that creates mayhem or not.
You could absolutely do that. I could connect to the hub and create a new connection. So this is a little tangent, but I could create another like a fork of Osmosis or like a fake Osmosis connected to the hub, like advertise my connection ID as actually this is like the connection ID to Osmosis, and you could probably trick some people into like transferring some tokens over there.
I always thought this was a very, very strange. But anyway, let's go sort of back on track. So osmosis, I'm on osmosis, and I want to send a transaction to Base. We're not going to talk in detail about what that does, but okay, I'm on osmosis. There are channels to Polymer, and then
the channel would be to Base, but it would go over Polymer.
So osmosis knows the channel is to Base.
It wouldn't know that it's like Base is in. There's social consensus around it being Base. Mm-hmm. But it's just two connection IDs. The two connection IDs could lead anywhere. It's just that by social consensus, people think it's Base. Yeah.
Okay. So on osmosis, I trigger an IBC transaction. The first hop it reaches is Polymer.
Yes. So the state of the packet is committed to on osmosis because osmosis implements IBC Go. So when osmosis says, I want to send a packet over this channel, that packet gets committed to osmosis' state. And now on the Base side, what Polymer does is it acts as the interceptor. So the IBC state is not managed by Base. The IBC state is managed by Polymer. Does that make sense?
Yeah. So Polymer is implementing the IBC counterparty here on behalf of Base.
Yes. Yeah.
So it says, okay, I see, and there's a relayer in the middle that's, I guess, is moving, or maybe you guys get rid of those, I don't know, but somebody needs to tell Polymer, like there was the state change in osmosis, there was an IBC transaction was initiated. Yes. So you pick this up, and now I'm curious what Polymer does with this information because Base doesn't have that IBC client, right? So what happens now?
Yeah, so Polymer takes the packet that was committed to on osmosis, and it says, I will receive this packet. But the packet is not executed. So we've separated the, obviously, IBC application layer between the IBC transport or core layer, and we separated the two. If you look at COSM WASM, how smart contracts are implemented there, it's a similar idea where in the COSM WASM VM, you can implement IBC modules as smart contracts, but the actual execution of IBC logic does not happen in COSM WASM. It happens in IBC Go. If that makes sense. This is happening all in the same Cosmos chain, except now we're saying that there's this EVM that's like remote on Base, and then there's like all this IBC logic on Polymer. So we execute the packet, we commit to the packet, but this packet's not executed.
Right.
The packet execution is async to Polymer, and on Polymer we have this local IBC connection between Polymer and we call the connected chain like a virtual chain. And we call the IBC commitment on behalf of that chain a virtual commitment. So we have this like local connection on Polymer that represents a connection. We call it a virtual connection to Base. And then another relayer would pick that packet up and then relay that to Base. So Base also has an IBC client for Polymer. So like the connection itself is still formed between the two chains. It's just that the statefulness of IBC or the actual commitment to the IBC data only happens on Polymer. So like once we've executed the packet on Base, we return the results of the execution onto Polymer, and we commit to that on Polymer before the acknowledgement can be returned back to osmosis.
Right.
Yeah.
But so now I'm slightly confused because you're saying like, so Base has an IBC client for Polymer. So did you guys deploy that or?
Yes, we would deploy that. Polymer is still, so like, because there's still two connections here, Base Base needs a way to verify that the information coming from Polymer is valid, and Polymer needs a way to verify that the execution of Base is valid, and same for osmosis to Polymer as well. So like the requirement of like counterparty clients or counterparty IBC clients is still a requirement.
So, but Base would be using, let's say, IBC Solidity, which you guys can deploy on Base without Base being sort of, without permission, changing the Base code bases.
Yeah. With the one exception being that IBC Solidity is a full implementation of IBC, including all the stateful, including all the commitments. Where ours is more of like a thin,
like a pared down version that focuses on the execution.
Yeah, exactly. Yeah.
Right. Okay. So that's a pretty complicated construction to sort of wrap my head around. I'm still processing it, but it feels like so what you've reached by this, and let's just confirm that, is that you can now you've now been able to talk from osmosis to base without base necessarily changing their code base to implement an IBC client on their side.
Yeah, and I think like long term, this is the model that chains are going to move towards in terms of IBC integrations in general. And we've been talking a lot with the IBC team at the ICF, and this is kind of potentially a preferred approach to, and like not just with Polymer, right? Like you can take IBC Go, you can run it as a separate process within the same chain. Like let me know if this makes sense or not. So like you can take, let's say you have this like IBC ABCI application. So like in a Cosmos SDK app, now you can say like I have multiple ABCI applications for my single Cosmos SDK chain. Mm-hmm. I have one ABCI application for IBC. And like that's kind of what like Polymer does. Like I am the ABCI app for IBC, and I will like provide IBC execution on your behalf. And then you have like the rest of your application logic, be it osmosis or some other like specific chain. And the IBC side is self-contained and can just be connected, but it's also asynchronous with respect to the actual VM. So this model is kind of like a step further from what's happening in CosmWasm to IBC Go today. So this is kind of like taking that and being like, okay, let's take it a step further. We'll split things up a little bit even more so we can kind of abstract some things away and standardize on some things.
This is reminding me of, I do believe Agoric implements, because they have a custom VM, they actually implement some of the sort of transaction types, which would be, or function calls, which would go straight through Cosmos SDK through IBC actually. So they talk to themselves. The VM talks to the chain via IBC for some specific transactions. It reminds me of this sort of construction.
Yeah, there are some similarities. So I'm not, I don't have like full context on exactly what Agoric's constructions look like, but I do understand that a lot of the, I'll say IBC features that we work with were pushed for and introduced by Agoric. For example, async acts, I believe was something that Agoric, had pushed forward because they were doing what you said, which was, there's like this IBC thing on this one end. There's all these kind of like Agoric JavaScript applications running in their VM. They want to be able to call between the two, but the execution is happening async to what's going on the IBC side. So I think there's some like things that we're building off of.
So to summarize, like we've gone pretty deep on sort of how Polymer works. Would this be what's called VIBC? What you guys call VIBC?
Yeah, this is what we're calling virtual IBC. I know Agoric calls it dynamic IBC. But I imagine there's some differences there.
That I don't know. I don't have full context of that. So, but let's just give it a name, right? So the construction, which puts a Polymer chain in the middle as sort of a clearinghouse for IBC packets going in from one chain to another chain, is called virtual IBC, and that doesn't require the target chain to actually have like an IBC client in the code base. Like I'm curious. How you'd compare this to other types of sort of interoperability? There are some well-known names: Wormhole, Axelar, Hyperlane. You name it. How would you sort of succinctly compare? No relation to ZK. How do you compare what you guys are doing to what these guys are building?
Yeah, I would say that if I walk, like maybe we can do like a quick run through of the history of. Or the evolution of interop protocols, as narrated by myself. So I
story time, folks.
I feel like we started in a place where folks were just doing peer-to-peer initially. So one of the first to market, like Layer 0 was one of the first to market. You had two styles. You had peer-to-peer, and then you had hub and spoke that came later. So like Axelar, I'll say Axelar, Wormhole. You can even argue that Chainlink CCIP, because the oracles kind of sit in the middle, is also somewhat like hub and spoke. And then with like your like Layer Zeros or Hyperlanes, these are peer-to-peer. You deploy some set of smart contracts. You need kind of a point-to-point connections between all the peers that want to communicate with one another. So these are the two current operating models. We wanted to improve on this in one specific way because we saw that a lot of activity is going to flow to rollups, and for rollups to communicate, there's a reason why you would build a rollup in the first place. you build a rollup because you get a trust minimized like bridge access to the L1. You also get security from the L1. You get trust minimized communication between L2s if you use the native bridge. It does take a long time if you use like Optimism and Base. You want to do a full round trip, it's going to take you 14 days. It's kind of slow.
So the fraud precipitation period, yeah.
Yes, but there's these different properties that you can retain. It's fine with peer-to-peer. So like if you have a peer-to-peer network deployed on top of these rollups, you can, if you use a native bridge for verification, you can technically enforce the same trust minimized properties of rollup-to-rollup communication. But if you add a hub, and the hub is not of the same domain as the rollup ecosystem is, then you're introducing a random third party that breaks the trust model of rollup-to-rollup communication. So we wanted to introduce this concept of domain-specific interoperability. It's the idea of introducing a domain-specific hub. So a hub that belongs to Ethereum, which is why we're building an Ethereum L2, that can provide scalable connectivity. So you don't have to establish an n-squared number of connections. You can get connectivity with n connections. And also while retaining the same security properties of, or trust minimized security properties of rollup-to-rollup communication. So there's like a third operating model that we're working on. And we believe that we're the first.
And when you say same domain, is that defined by sort of like a common settlement layer, DA layer? Like these have to be the same, or what's when you say domain specific, what's the domain specified by?
It's all of these properties. If you use a different settlement layer, that your domain now shifts a little bit. If you change the DA layer, the security properties of your protocol shift. Like using Ethereum for DA is not the same as using EigenDA, is not the same as using Celestia DA.
Right, which brings us to this sort of broader topic of interoperability for the modular world. So if we thought it's complicated for monolithic chains, it's about to get much more funky. As like right now, you have basically different sort of, let's say, service providers for these layers, and any sort of interop needs to be aware of what all these parts of the stack are doing. So I think like we're about to get one level deeper. So everybody brace. Let's start with, what's modularity? How does that connect to rollups? How is the stack split up? Can you take us through what's a modular chain construction?
Yeah, so I think for a long time, folks had a very monolithic view of chains, and that's how they were designed. But with the influx of all these different alt DA layers, kind of like the modular narrative that Celestia has been pushing, folks have started to kind of expand how they think about blockchains, and they realize that like blockchains can be of many parts. You can have a data availability layer, you can have a consensus layer, you can have an execution layer, you can have a settlement layer. You can have all these different ingredients that you make up a single logical chain, and the logical chain can be represented in like many different ways. So to prove that the state transition function of a chain is valid, you're going to have to prove each of these parts individually and as a whole, and tie them and somehow tie them together to convince yourself that I'm looking at this chain that is actually like composed of all these different parts from all these different places, and that I can be convinced that this chain is now stepped forward a single block, if that makes sense.
Is that something you guys are focusing on right now because you want to be, partners in this L2 world and be the interop layer for ETH L2s? Is that like your main focus right now?
Yes. So we are focused on trying to verify all the properties of the rollups that are communicating with one another. So like we want to be able to verify that they have settled properly, they have reached some level of finality, that there is validity to the state transition itself, and we want to verify these things via the clients that we're working.
Is this in the research phase right now, or are you guys like writing code? Have you worked out? Okay, these are the pieces we need, and now you're writing these individual, let's say, I guess different light clients. Are you in this phase, or are you more sort of like at the drawing board?
Oh, we're already about to launch testnet in a month or so. The approach has been, since we're now targeting a specific domain, we can actually rely, to give you an example of a client we're working on, we can actually rely on the Ethereum L1 for verification. Since when we connect to all of these different rollups on Ethereum, because we're an Ethereum rollup ourselves, we can say if a rollup has settled onto Ethereum, and we'll check the contracts that they're using to settle with. If you use the native bridge, they'll implement, I'm just going to talk about optimistic rollups right now. They're going to implement some fraud window, let's say it's 7 days. If, as I mentioned earlier, if you want to use the native bridge, you do the round trip, it's going to take you 14 days. With the clients that we're working on, we can say that, well, you can use the same verification mechanism and we'll make it configurable. We can say that we're okay with anywhere between 14 days all the way down to 3 hours. And 3 hours would be, it's approximately about an hour to publish or propose new L2 state roots. And I believe they published DA to the batch inbox on Ethereum, like roughly like every 2 to 4 minutes. So you can have with, I guess, like, default verification using like the existing settlement contracts on as often as they propose, like as low as 3 hours. Obviously that's, risky because you have not waited the full fraud window. Someone can submit a fraud proof and cause a rollback. But that is a risk that you can take on if you're comfortable with it. But we can also talk about other mechanisms to essentially like add pre-confirmations to the validity of a rollup on top to further secure this communication.
Yeah, I guess this is an interesting topic because, like, in my mind, obviously, if you want to, say, accelerate the time in which you consider the transaction like completed, or the let's say the funds to be valid to use on the other chain, introduces risk, as you said. So in my mind, the configurability would have to sort of do some sort of analysis, like for values up to XYZ. Yes. I'm happy with a shorter time window and I'm willing to take the risk because I'll reimburse, in case if there's a problem, I'll do the reimbursement. But so is that what you're thinking of? Just like managing the risk level?
Yes. So like there's obviously cost of censorship associated with censoring fraud proofs. They become I would say like very expensive as time goes on. We haven't done the economic calculations yet, but we are planning on doing some exploration there with some partners to kind of give people a sense of like what is the actual estimated economic cost of censorship. So like how much, kind of trying to add like a dollar value to the security level here.
To have to sort of look at amount at risk versus security level. Is that?
Yes.
Is that the, okay. And as you're developing the interop stack, like what are the pieces you've already developed? If you go back to, okay, you guys are doing interop between, say, two different L2s, they're both optimistic, and they both settle to Ethereum. Let's make some assumptions, or I guess let's if you can talk about a recent example, let's make some assumptions, and then what are the pieces that you guys have already written?
Yeah, so Virtual IBC we've had for some time now. Previously, we were working on like a number of different IBC clients. We also had a ZK Tendermint thing that we're working on. By shifting to working on an L2, we no longer have to, verify Ethereum consensus. We derive our state from Ethereum, and Ethereum no longer has to verify our consensus because we don't have consensus as an L2. Just the settlement contracts. We've written an IBC client that can interpret the OP stacks settlement contracts, their bedrock contracts. But we would have to write I'll say like a specific client that can interpret the contracts for different rollup stacks as well in the future. But with the OP client written, you can essentially permissionlessly integrate Polymer into any OP stack rollup. Let's say like you're experimenting, you want to deploy an OP stack rollup. You can essentially add an IBC connection while verifying your rollup settlement onto Ethereum, connected to Polymer without asking anyone for permission to do so.
Right, because they fork the same contracts, deploy a new copy. So obviously, like whatever you've written will also be able to understand the new contract. So that's why now anybody can connect to that rollup permissionlessly.
Yes. Yeah. So they can create an instance of the client. So they would create an instance of the OP client. They'll say that this client is configured to talk to this specific chain that I just created, and include all the initiation parameters, and now you have this like new unique connection to your new chain.
So are you guys expecting there to be many layer twos? Are you expecting, what's the future that you guys are building for? Are you in the camp that expects 1,000 L2s or in the camp that expects 50?
So it depends on what we're talking about. I think for EVM L2s, I think 50 sounds like a lot. I'm thinking that 50 is probably the upper bound for number of like meaningful EVM L2s. I'll be very surprised if we were in a world with millions of meaningful EVM L2s. I'm actually a lot more bullish on the idea of like app rollups. There's a number of projects both in the Cosmos and elsewhere that talk about app rollups. From our perspective, it's also why we, when the other goal of ours by building this Ethereum L2 is we went ahead and we took the Cosmos SDK and the OP stack and we combined the two. So normally the OP stack uses OP-Geth as the execution engine or other EVM execution or EVM/Ethereum style execution engines. We replaced the execution engine completely with a Cosmos SDK ABCI application. So now you can write your application with Cosmos SDK and you can deploy it as a rollup onto Ethereum. And I'm much more bullish on this because it allows builders to hyper optimize their chain for the workload that they care about. And also there's a lot more customization that you can do outside of the VM layer. You can take like a Skip's block SDK, you can have it plugged into potentially a shared or just even like a single sequencer and inform it of things that I guess block building rules that you care about. There's a lot of other interesting things that you can do. Obviously, there's a growing, I would say, like catalog of Cosmos SDK modules that I expect to just like grow with time, and I expect the framework itself to become more popular as well.
One of the key pain points of IBC is relaying, right? I mean, relaying still costs it costs a lot of money. It's unclear how to reimburse relayers. Relayers still have difficulties sort of managing this economically. There have been some talk about the fee modules, etc., that would sort of solve this, but I'm not sure if this is going anywhere. What's your view of the future? Like, will relayers be needed or not? What do you think?
So relayers will be needed for now, as long as the world is not in a place where and we could talk about like the end state in a little bit later, but as long as there is being implemented at the smart contract level, it's impossible for you to kind of standardize on some sort of like P2P network overlay that can replace relayers, if that makes sense. It would be quite difficult to do without making significant changes beneath the VM layer. What we can do in the short term is there's ICS 29 in the Cosmos. I believe that there's probably starting to roll it out soon. They're waiting on channel upgradability. You'd have to upgrade existing channels. The relayers are, I'll say, like ICS 29 aware. That means that they are aware of the fees there. But I think there still needs to be some work still needs to be some work done to ensure that the relayers can determine whether or not they'll be profitable relaying a packet. Since it's not just enough that there is a fee, you kind of also have to ask the question of like, okay, I see a fee. Is it like how much profit will I make actually like relaying this packet? That's another question you want to answer. We work with Catalyst. Catalyst is an AMM working on building unified liquidity for millions of rollups. And Catalyst has an incentivization scheme that's a little bit different from ICS 29 that we've also integrated. So when you use Polymer, you'll be able to pick and choose which type of incentive mechanism you want to stack into your application.
Can you give me some examples of these incentive mechanisms? I mean, how do they differ from the ICS 29?
Yeah, when Catalyst made their generalized incentives protocol, they didn't want to make it a fixed fee. They wanted to add some decay. They wanted to incentivize a relayer to relay sooner, since they wanted to optimize for UX. So like, I think the default logic, I believe, is you add some fee to the packet. And if the relayer, and you add some like decay logic, and if the relayer relays it immediately, they can be qualified for like 100% of the reward. And if it's like, after 30 seconds, some decay factor is applied. After a minute, some decay factor is applied, and so on.
But it's only the first relayer that gets rewarded, just like in ISIS 29. Is that correct? So if you usually have multiple relayers monitoring the channel, and they'll all pick up the packet, right? That's some of the waste that's happening on chains now, and all of them pay for the transaction on the target chain, just trying to ship it there. But essentially, so the big question is, how do you reward these guys, which you were, I guess, alluding to earlier? So the Catalyst construction makes this even more competitive, if I understand it right, because it will start reducing the price depending on how late the relayer number one is. But if you're relaying, you still don't know if you're going to be number one.
Yes. Unfortunately, no. Yeah.
Okay. Yeah. Right. Life's hard for relayers. Thanks for doing the work, guys. It's totally not easy. So you were talking about the end state. I'd be interested in your sort of vision of what the future of the crypto ecosystem looks like, and what interop is going to look like.
Yeah. So I think in the long-term time horizon, every chain or chain framework will enshrine some interoperability standard. Be it IBC or some other future standard that doesn't yet exist, but we kind of already see it. So if you look at IBC alone, it has, I would say, like market penetration into not just the Cosmos SDK. The Sovereign SDK recently added support. I believe Rollkit is going to add support for it as well. So it'll have penetration into multiple ecosystems. Also, with our work on bringing Cosmos SDK rollups to Ethereum. Now, like Ethereum L2s can have like natively enshrined IBC as well. So there's significant market penetration already. But in this world where every chain or chain framework enshrines a single interoperability standard, I'm anticipating that we'll do things like get rid of these relayers. As you mentioned, even if we have incentives, relayers will compete, and one will succeed, and the failing transactions will not be rewarded. And in a world where you can establish a P2P overlay, the job of a relay and confirming like cross-chain transactions is now the responsibility of the validator set of the chains that are connected. So now there's it's baked in protocol for forwarding the proofs that something happened, emitting something over the network that we saw a packet being committed. And it would just be expected to be processed by the different val sets. In terms of incentives, there's multiple ways you can go about it. Chains can like emit incentives and have different chains hold interchain accounts on their counterparts. It could be a very interesting setup, and like different ways you can explore on the incentive side.
So I'm interested. I'm wondering what the future will look like. As we started out discussing, there seems to be a lot of fragmentation. Yeah. So let's hope you guys can unify the crypto world and make it all connected.
Yeah. I think the fragmentation bit is, and especially the maintenance cost bit is really interesting. I sincerely don't believe that the current approach taken by existing solutions will scale. If you have to implement interop at the VM layer, you have to account for the chain internals of every new chain type that's connected to the network. Imagine this at internet scale. So, you have like billions of devices connected to the internet, and maybe let's say there's like millions of device types. So the second you add a new device type, you have to, if you have to then modify the networking library or like the TCP/IP library across all these other millions of devices to account for this new device type, it sounds like a horrendously painful developer experience. It doesn't work like this in Web 2, but we are in that state in Web 3 today.
Okay, looking to you guys to fix it then.
Yeah.
Well, thanks very much for coming on board. This was most instructive. I definitely learned something new about IBC today.
Yeah, thanks, Martin. Yeah.
All right, see you later. See you around. Have a good one.